All right, so numbers 11 and 12, they're logarithms that we have to expand, but it kind of breaches into a topic which is a part of your algebra journey, but I guess we'll see. So I could, one of the properties of radicals is separate this into three separate radicals. I could write log and then put cube root of x times the cube root of y times the cube root of z. I can break it into separate three. Now, obviously, you could say, well, then that means I can write log cube root of x plus log cube root of y plus log cube root of z. And naturally, like I would leave it like that. Now, with logarithms, especially when you are expanding, they don't want you to have any, they don't want you to write square roots or cube roots inside. They want you to get them out and write them in the front. So this would have to branch back into some knowledge of rational exponents. And here's what I mean by rational exponents. So if I wrote this, 9 to the 1/2 power, do you realize that that is the same as the square root of 9? These are literally the same exact thing. Whenever you have a rational exponent, the number on top is the power, obviously, because I like to think the number on top is in control or it has the power. And the number on bottom is the root. Just like a tree, at the bottom of the tree underground are the roots. So if you were to rewrite this, this would be 2 root 9 all to the first power, which, again, square roots come in existence because we don't write it, but there's an invisible 2 in front, and we don't have to write the 1 because anything to the first power is itself. So that's how that becomes the square root of 9. Same thing applies. Oh, by the way, you can go backwards. You can go in between these two forms. Like you can go square root of 9 and go to 9 to the 1/2 power, or you can go 9 to the 1/2 power equals the square root of 9. You could do either or. It doesn't matter what order you go in. But obviously, it depends on what type of equation you're dealing with. So if I had something like this, the cube root of 8, okay, we obviously know that's 2. But, again, I notice that my root is 3, and even though it's not written, there's an invisible 1 exponent. I could write this as 8 to the 1/3 power. And they're the same exact thing. So, back here in number 11, notice how it's the cube root of x. What they want is for you to write log x to the 1/3 power. And same thing for y, so y to the 1/3 power. And same thing for z, z to the 1/3 power. So, you have all those expressions, and then, of course, like we've already discussed, you can move the exponents to the front of the logarithms. So it would be 1/3 log x plus 1/3 log y plus 1/3 log z. Okay, so that would, you have to branch way back into your knowledge of rational exponents in order to know how to do this. And so let's go ahead and do the next example there, number 12, to kind of help us out there. But again, the important notes are right here. It's on the right side of the screen. So that's kind of how you go from radical form to exponential form. So let's talk about number 12, and I'll leave number 11 there for us to reference. Okay, so I'm multiplying, so that means I can create multiple logarithms and expand them using addition. So I could write log x plus log y plus log z squared, which obviously I can move the 2 in front, so it would be log x plus log y equals, plus 2 log z. Okay, so that is how you deal with radicals inside logarithms. You have to write them as rational exponents and then move them to the front of the logarithm. So that's how you deal with rational exponents and radicals.